In this problem, we are given a LTI system. The input and output of this LTI system are also given, and we are asked to determine the impulse response of the system, which is ht. We know that in LTI system, if the input is xt, the output is equal to the convolution of the input with the impulse response. We also know that if the input is delta t, then the output is equal to ht. This ht is called the impulse response, meaning the response of the system to a unit impulse input. Since the system is time invariant, according to the time invariance property, if the input is shifted by tau, the output will also be shifted by tau. Now, if we look at the given input, we can see that it is a shifted impulse. Therefore, the output will be h t minus tau. So, h t minus tau is equal to u t minus tau minus u t minus 2 tau. Using the time invariance property, we can now determine ht. We conclude that ht is equal to u t minus u t minus tau. Now, if we want to sketch ht, we know that ut, the unit step function, is equal to 1 for t greater than 0 and 0 for t less than 0. Similarly, ut minus tau is the same step function shifted to the right by tau. If we subtract these two functions, we get a rectangular pulse that is equal to 1 from 0 to tau and 0 elsewhere. So, ht is equal to 1 for t between 0 and tau and 0 elsewhere. The next part of the question asks whether the system is memoryless or with memory. According to the definition, an LTI system is memoryless if ht is 0 for all t not equal to 0. If you look at ht, you can see that it is not 0 only at t equals 0. It exists over an interval from 0 to tau. Therefore, the system is with memory. The next question asks whether the system is causal or non-causal. For a continuous time LTI system, it is causal if ht is 0 for all t less than 0. If you look at ht, you can see that it's 0 for all negative t. Therefore, the system is causal. The next question asks whether the system is stable or unstable. An LTI system is stable if the integral from minus infinity to plus infinity of the absolute value of ht is finite. If you look at ht, the area under the curve is simply 1 multiplied by tau, which is a finite value. Therefore, the system is stable. In this problem, we determine the impulse response of an LTI system using the given input and output. Then we examine three properties: memory, causality, and stability. If you found this explanation helpful, you can check out more solved problems on this channel.